My name's Amos. I'm the Director of Robotic Systems. We are an engineering consultancy based out of Newcastle, Australia. We specialise in electronics, hardware development, LabVIEW and other software languages, and we also have a manufacturing line. Our big promise to our customers is that we accelerate the journey from idea to a manufactured device that our customers ultimately own and sell. And in the last 12 months, we've had 4 patents filed by our customers on technology we've developed on their behalf. We've won a couple of industry awards and we've shipped $3 million worth of product from our facility. We're fortunate enough to count some of the largest mining and scientific companies as our key customers, and we do a lot of LabVIEW. What started out as a one-person engineering consultancy in 2012 is now at 11 full-time staff, and we've done projects from mobile 3D laser scanners, weird geolocation systems, high-speed vision systems, and industrial control systems for mining explosives vehicles, all of which are using LabVIEW. So also guys, just as we're kind of going along here, please feel free to jump in and ask me questions. I really don't think I'm going to make the whole hour, so I'll see how we go. And so where did this start? Like this, for me, there's been a lot of great presentations throughout this program and a lot of different frameworks out there of different ways you can program LabVIEW. But today I wanted to show you one that has really kind of come out of the sort of projects that we do, which seem to be these typically over 8-week engagements where there's high UI involvement. Typically what's going on in the code is there'll be a very small portion of the code that holds some very high complex intellectual property, and that'll represent maybe half the project, and then the other half of the project is this user interface that's kind of corralling everything around it. The two of which are all nowadays in 2020 are equally important. You can't, no longer can you just have something that's, you know, a great piece of IP with no UI that works with it really well. It's not acceptable anymore. It's got to have something that works really well. So this is not a UI framework thing. This is a general structure thing to be able to make bigger applications that can run for years and not end up in a total shit fight, as I'm sure we've all experienced. So specifically, the problem we need to solve at Robotic Systems is not so much of a what is the most pure, highest executing speed VI, but we're really trying to code not for ourselves, but for the developer next to us. And what that means is that we needed to come up with a structure that allowed us to easily do a couple of these, probably these 4 big things. And that is, we need to be able to section off code into areas where it's most likely to be related to. So VIs containing, or UIs that contain all of the code related to that UI's functionality, and none of the other sections of the code base for the project. I really needed to have my teams of developers being able to easily understand what each of them have done without kind of opening up somebody else's VI and just then having to spend a bunch of time trying to work out what their teammate had actually done, or what their intention was, or where they should go in the code to look at something. I wanted to kind of come up with a way in which we could design code consistently, kind of like bricklaying, so you know that when you come up to open up a VI, there's some common elements that you know where they're going to be, and they can just be arranged in a easily understandable format. There are a lot of frameworks out there that are very complex, and they're really only suitable for the most advanced LabVIEW operators. that doesn't really work for us as an engineering consultancy, because we need to be able to onboard team members quickly and get them turning out useful work quickly. So we needed to be able to have a structure that only requires very basic NI training. So by basic, I mean the standardized training packages, really up to basically the developer level. And I thought that if we required training beyond developer level, it's really going to put too much of a burden on the team, because the burden on the recruiting process, because in Australia, we just don't have that many LabVIEW developers. National Instruments, 6 month start of the year, has abandoned Australia. We now no longer have our own National Instruments representatives. It goes through a master distributor who are great, but NI has pulled out of Australia. So there really isn't the developer base that there is overseas. So we need to be able to train people and be able to train them quickly and with the available course materials, and not be reliant on any non-official training. And the final thing is that we needed to be able to work well with the LabVIEW binary files and source control. So something as simple as, which I have constantly explained to text programmers, is the merging of the binary files in LabVIEW. Yes, it is possible, but no, it's not a good idea. We've never seen it work well in the last 10 years of programming LabVIEW. I don't know if it's ever going to work well. An easier solution is to kind of just split up the VIs. So that's really, in a nutshell, the problems I'm looking to solve. Is it's really all around the teaming side of LabVIEW and how I can create a structure that hits all these boxes. So we didn't start out to kind of one day be like, we're going to build this one structure to rule them all. This kind of came about organically over the years of doing all these different projects over the last 10 years or so, of what worked on them and what didn't work on them. And so what I want to share with you now is, let's have a bit of a look at this structure. And I also want to give you guys the code after this, so you can have a bit of a look at it. The idea behind this is that it's designed very deliberately to be absolutely as simplistic as possible. If things are too hard, they won't get done, because the team will do them once. They won't then really kind of appreciate the level of why they're doing it, and ultimately it'll just never happen again. It'll just go back to structures that every programmer programs in their own style, and that's really not useful for a high-performing development team, which basically only gets paid on successful outcomes of projects. Okay, so also, if this is starting to not make a lot of sense, please just somebody ask a question, just stop me. This is not a rehearsed presentation I'm giving. It's really more of just like a presentation of our internal training materials. So let's start with the project. The anatomy of the project, every single one of our projects, pretty much, you guys will recognize this. If you've done any of the LabVIEW training, I don't know if it's still like this, but I think I'm certain it would be. But there's essentially a main function at the top. We've got a data folder, we've got a sub-VI folder, and we've got a controls folder. That's pretty much it. There's not a lot, so I wanted to basically take this structure that is at the high level of a very simple application that you do in the certified LabVIEW developer exam, and I started to think, well, what if I could just replicate this structure again and again and again, all throughout the entire architecture of the project, so that a developer only needs to know this basically, this structure here of a global variable, a main VI, a data folder, a sub VI, and a controls folder. So we put together this structure that follows that all the way through, follows that kind of mantra all the way through. So starting at the main, I'll open that. We have what you all recognize as a very, very simple VI. What happens though is that, like, the one difference is that instead of it being a one UI at the top level to kind of rule them all, it's got nothing more than a subpanel container in it. And what we want to do is load up modules into the subpanel that we want the user to be able to interact with. So all the code's running all the time in the background. We use queues to be able to communicate messages between the code modules, and we use global variables to reflect state easily between stuff. So when this VI runs, the first thing that happens is that we get, well, I might just run it first. Kicks off, and all of the VIs in the background that get loaded into the subpanels all get started. And they get started and then they're just running continuously. And then from, say, a menu selection, at the top level VI, we just choose a different VI to insert into that subpanel. So that kind of gives you the idea of this is how we're presenting stuff to the user. So moving between screens, I think this kind of borrows a lot from some of the text-based programming languages and web-based programming languages, with the one difference being that all of the code is running at all the times. So let me just stop that. So how do we get there? Simply, we have this concept of what we call a subpanel manager, and this is probably the most complicated part of the system. And it exists as nothing more than a engine that just puts stuff into the subpanels. And it's got a couple of actions it does here. It displays screens, reverts screens, and closes screens, and that's it. And so now all the other VIs have the ability to control this remotely using queues to be able to effectively launch and hide items on the screens. That allows subpanels to launch another subpanel from within themselves, which is a very powerful concept, because it enables you to have nested buttons and nested logic and nested control routes that are very simple to implement. So the first thing you might notice is that it's not clear exactly where these modules are. So the modules of code are basically held here in the sub-VI folder. So under module 1. And this is the module of code that gets launched up and put into that subpanel VI. And just thinking kind of like, what's so special about this? And there's really nothing. Within the subpanels, the structure repeats. So you've got a main loop, a user events loop, and an event structure to enable interaction. Also have in there the queue system, which is using nothing more than standard queues to be able to communicate data between the screens. And importantly, every module has its own queue, so that enables each module to be able to just have the instructions that it's able to deal with. So it's kind of like its own little API. So every single screen, it automatically has an API you can call from any other screen to make it do stuff. Each of the screens are non-locking. So, and this is an important feature because it allows you to easily start, stop, and move through states. So each of the queues actually time out, and when they time out, i.e. nobody sent them a message to do, they defer back to the user events. So then go into the user event case, in which case where they can then have the ability to have a user press a button on them. And so now you've kind of got the best of both worlds, in that you've got remote control ability and you've got the user still being able to click buttons in it and make it work. Any logic for that particular screen is then also contained within these states, and it gets called by the same API that a remote VI would call. So, for instance, instead of at the start of every VI or the first call, he will be called the initialize state. So it'll go to module 1, and the first thing it'll fire is initialize, and then in the initialize, this does everything that initializes the VI. It might load some file stuff. It might set up the screen for being a subpanel, and all this stuff becomes very generic. It becomes very familiar for developers approaching another developer's code. So they can work with one person A developing a screen, second person developing a screen, and both of them are going to be following a very similar structure that never ever seems to get painted into a corner, as long as you stick by the rules. So if you recall this click action 2 button here, it simplifies the set next module, set next state button, set next state VI, and launches off the action 2 button, and that'll execute the code in here. We use a variant to pass all the data for these queues. So what that means is that you can move any piece of data between any of the screens, but it's delineated by the concept of an action and then the data. So the action tells you what to do with the data, and the data can then just be anything else. And this enables the developers to be able to be very clear and explicit in what they're trying to send. It also makes for easily updated event structures that automatically happen when you just update the type def here, which is a different case to if you're using something like strings, where you don't get any of that automated updating that you would get through the enums. So it's all about those little time savings, and all those little bugs that come out of like a seemingly innocuous change doesn't actually flow through to the system, and you get a break, which is usually a very embarrassing test event occurrence. Okay, so that module structure repeats again and again and again for every single VI in the project. You can communicate you can communicate one VI to any other VI, and you've got a simplistic main structure that doesn't really change. So these are all some pretty good wins we've found to really basically put the afterburners on to the development team to be able to work alongside each other really well. From a dev point of view, I don't know how many other people have experienced this, but just the simple fact of being able to talk to another person in your development team, say, okay, I'm in this screen, you go to another screen and do something. That simple communication is very effective in preventing code clashes, which I've basically never seen resolved cleanly in LabVIEW. So what we do on a lot of the development teams is just on Slack, when somebody's going into a screen, somebody will just fire a message off in Slack saying, going into the module 1 screen, and then if anybody sees that message and they're in there, then they know to say something before anything else goes on. And that, of course, doesn't save the old problem of still two people not talking, but it really cuts down the amount of chances of that actually happening and hitting that code clash. What else? Variables. Now, I don't know whether people have any major objections to global variables, but we use them for everything other than communicating a command. So if you want to send a command to make a screen do something, use the queue. If you want to just reflect a state, like say maybe you just want to monitor a status of one of the other screens, then you can use a variable. And by creating a global variable, it's super quick to actually just drop on something onto the globals, and then you've got that global available for that screen. You don't really need to then create a functional global variable or do anything like that, because it's just not necessary. Any of that time spent creating an FGV is kind of just out the window. Now you can use this variable wherever you want. And if I want to pick up some data from one of my colleagues' screens, the first place I'm going to go look is I'm going to look at the variables he's got available to me. So it's kind of like, the public methods. And then I'm going to look at what queues, what messages I can get sent. I can look at what messages I could put into, what actions I could put into his screen to be able to get him to send me something I need. And I'm just going to repeat those series of actions. So the big difference here is you don't need to know anything other than the basic LabVIEW structures to be able to use this state reflection. All you need to know is that you only use it for that, and if you want to send a command, you use the queuing system. So I thought I might just hold it there. Is this useful for people? I mean, I can't see anybody's faces. I might just stop the share. Where are we at? Where are we at?
So Adam, can you hear me?
Yeah, I can hear you.
Okay, so no questions on the chat so far, but I was wondering, just as you were talking about the globals, just 2 hours ago, Darren Ettinger was having a presentation and also covering the topics of globals, and so globals are not as bad as they as we thought they were, or as we said they would be.
Yeah.
Do you have any kind of access restrictions on the globals, or is everybody just able to read and write on each global data on your submodules?
Great question. So the variables the global variables are basically read only. You really don't want to be writing anything to them, because at write you're trying to communicate a state change. So and that's a really good point, and that's something we could probably improve, is that as part of the training, is that the globals are read only outside of your screen. So of course, if you are within the screen that global belongs to, writing to it is of course necessary to update it. But if you were outside of that screen and you write into that global, that would really kind of be a recipe for misery. And that's where I see a lot of code complexity coming from. People trying to use global variables to try to change states of stuff. That's really not a great way to develop quickly, and it's kind of invites a bit of a bug factory, as you're constantly trying to latch, state changes in and out of the globals whilst, within time windows. As long as you kind of stick to the mantra of, I want to change something, I'm going to use the user queue, which seems to never really go wrong.
Okay, cool, thanks. So there's been questions on the chat. So Ali Azad was asking, what problems did you have with using the framework, like lessons learned, something like that?
Lessons learned, yeah, absolutely. With machine vision, there are some LabVIEW bugs. They're getting better all the time, but subpanels seem to, in the earlier version, we've been using this the last 5 years, there was some subpanel foolery going on that has seemed to have been alleviated in recent years. There's the other big lesson learned is that the team has to stick to the rules. I think, and this is probably true of all these frameworks, and is that whatever way you go, you need to be able to have a set of rules by which you're playing by, and a disciplined game to play. Otherwise, if you kind of let somebody break the architecture in one area, it all very quickly goes downhill. But that is also a good way to incorporate some jovial office bullying, people kind of going outside of that area. But because it's such a simple process, it really is a lot of, it is actually the easiest path to go to get things done. Maybe one of the lessons learned is that when you're actually debugging, it can be slightly annoying in that you have to have the VI running in like opening development mode before you kick off your execution if you wanted to probe the block diagram, because it'll get loaded by the subpanel launcher, and then you won't be able to access its block diagram while it's running. You have to kind of stop it and start. So that's a slightly annoying thing, but in the grand scheme of things, it's worth it.
Okay, thanks. Next question, Gabriel Safar. Hello, Adam. Do you have situations where a customer requires to display parts that you have implemented in multiple modules, subpanels, and what do you do in that kind of situation? So it's basically, as the way I understand it, what do you do if you need to display more than one subpanel?
Yeah, we do. So on this, I'll just reshare. So displaying more than one subpanel on this this project, it's got two. I'll just make it really big. Got two touch screens, so they're two separate monitors. So we've actually got one big VI, and then we've got two subpanels. So we have a left subpanel and a right subpanel. So then we can launch any VI into either subpanel to display it. So yeah, you can add any number of subpanels, and you just keep adding more subpanels to your block diagram, adding more references, and yeah, just pointing them at the right spot.
Okay, so next question by Andreas Fichtner regarding project organization. It seems you do not use LabVIEW. So it's only for. Is there a reason to do that?
No LabVIEW libraries. This is going to get into a bit of personal opinion here, but I don't fully have a handle on the library, what the library solve for LabVIEW. It only seems to get us into bad situations when we've got these libraries kicking around. They're usually not supported by NI. If they're not supported by NI, we typically won't use them. And the reason for that is just around support, because if we get painted into a corner, we need to be able to ring people to get things solved. The other thing is that the libraries are a bit harder to manage, require a higher skill level for the team. And we want to stick to the mantra of being as simple as possible, because the problems are within the code, within the projects themselves, not the code. But yeah, no, we don't use libraries at all.
Okay, so libraries, just to make that clear, libraries as in LabVIEW. So, but you do use libraries from other sources.
Yeah, that's right.
Okay, cool, thanks. So Aaron Gelfand writes, in your obtain queue reference wrappers that you use first call, you pass the error input into the obtain queue. Isn't that dangerous, as an incoming error would result in invalid queue reference for the entire lifespan of a program?
You are 100% correct. So well spotted. You should apply for a job at Robotic Systems. So we are hiring. So yes, that is a problem with that particular example, and that is a definite problem. In the later versions of this training, there's actually a merge errors that happens, and it passes through, because that will occur.
Okay, Leah Edwards is asking a question. How do you like your documentation done? Do you have documentation outside of LabVIEW too?
No, generally. There's no documentation outside of LabVIEW, and the reason is because Our customers are paying us basically by the hour, and the first thing they strike off is documentation. So what does that mean? That we can't just not do anything. We have to, of course, deliver documentation, but the code has to be self-documenting. So the first thing we do to minimize documentation is to use the code itself. The code has got to be very verbose in its names of stuff. So a VI is basically got to describe what its function is. And if you can't succinctly describe your VI, then you're probably a bit lost in what you're actually trying to achieve with that VI. So we rarely do, in fact, we've never done, but just scanning my mind now, we've never been paid to write code-based documentation. Of course, to document how the system works and how the machine works, but the code itself, no, it's essentially got to be self-documenting, and that's why these repeating simple structures are so important to us.
Okay, thanks. Another question by Gabriel Safar. How do you reconcile the command processor of a module and the event structure? If the command processor is constantly executed, for example, acting as a state machine for 30 minutes, are these events filtered somehow?
Yeah, so if you are in a situation where that is the case, what we'll usually end up doing is we'll have within each of the modules a separate engine that's doing something to do with that process. So if you've got, oops, I'm not sharing. If you've got something that needs to do that, then spin it in a separate loop down below. You don't need to put it in that top sequence. The frequency of that happening though, so let's jump into a module. So essentially, this one's not completed unit. So the question was, if say you had an event going off all the time here, and it was hitting action 1, just continually smashing action 1. Yeah, then what's going to happen is that this will get stuck, and what the user will be clicking buttons on the screen and it'll look like it's frozen. So what you really want to do is then have another loop down here and re-queue that action to then spin in a separate engine down here that then executes whatever that task is. It's critical that this task in here is non-blocking, so you don't want to spin within these. You want to be able to put it in a separate spot, or put it as a separate screen, really. If there's a screen where you have an action that's spinning for 30 minutes, say, that's a perfect opportunity to make a new screen. And that screen has nothing more than that action that is grinding away for 30 minutes and maybe an indicator for a status. These screens all don't have to be visible. They can run just in the background and never get shown. That's acceptable too.
Yeah, thanks. Okay, Gabriel says thank you. Another question from my side is, how big is the degree of reuse between projects? So it seems that your projects, or it looks to me that your projects are kind of one-off. So with the kind of tight coupling I see in your architecture, how big is the reuse indeed?
Limited. There's some, the structure gets reused. In terms of the blocks of code themselves, it's almost nothing. Because if I'll just jump back to the share, I mean, we go from developing, machine vision systems that get mounted on drones to explosives vehicles to 3D camera systems. There's really limited overlap between them, and like 3D laser scanning systems. The core of them is just not overlapping a lot. This problem here we had of creating a structure that can deal with all the variability that gets reused, logging errors and user events like clicking buttons on the screen that gets reused. But beyond that, there's really no other functions. I mean, we pretty much hammer, you know, all the OpenG stuff. That's got some great functions in it. But yeah, there's almost nothing that gets carried out between the projects. And just because that's because there's nothing worthwhile carrying it. All right. So yeah, I guess that's about all I've got for you guys. There's, in terms of other content, I'm not sure whether I explained this super well, but we'll see. I don't know. Like and subscribe, I guess. But while we've got a bit of time, if there are any developers here that are interested, you know, I guess some of the projects that we do, and would like to join the team at Robotic Systems, developing LabVIEW, please shoot us an email at jobs2020 at Robotic Systems. We are keen to talk to LabVIEW developers, and really keen to talk to people that are very passionate about LabVIEW, because I'm passionate about LabVIEW. It's how I got started. It's how this business got started. And I'm really looking to connect with other people that are like-minded. Yeah, if nothing else, if not to join the team, but to have a chat. And if you're in Australia, definitely have a beer with. All right, so I'm not sure what happens next.
Sorry, my microphone was muted. I was talking the whole time. I was just wondering because I was getting no response. Sorry. Okay, sorry. Patrick was asking how many. It's basically 3 questions in one. So, how many modules does your typical project have?
Typical project is we've got projects that we've been ongoing now for over 8 years. There's that one project has, I think, 25 modules, different screens, and it's quite broken apart, and it's quite good. It's so that's the biggest. We would probably say anything less than, say, 4 modules. So what would be an average? Like an average would probably be at least 10. I'd say at least 10.
Okay. Does each module speak with each other?
Absolutely, and they speak via the queues. So they can send a message to any module, can send any other message, so any message to any other module by just queuing up a message. So you can pick up the set next state, which essentially allows you to queue any message and put it into any other VI, and be able to control it and send it messages and make it do wonderful things.
Okay, performance-wise, did you hit any limits at some point which made you think to change to a more robust architecture, or not at all?
We've never hit a performance limit with it. It's never gotten itself into a situation where the architecture itself is the limiting factor, because when nothing's happening on it, nothing's happening. So if all the screens are sitting there idling, all that's occurring is that this event case, this DQ is timing out. It's then going into the user events case, where it's going to process a user event, which of course will time out after 10 milliseconds, and then it's going to go back around to it. And even if you have 25 modules all doing that simultaneously, nothing's going on. So there's really no CPU load regardless of the scale. So it doesn't really matter how many modules you have. You always basically marry up with the standard NI performance of using this dequeuing event structure.
Okay, thanks. Okay, Patrick says thank you. Can you please reshare the email address so people can contact you?
Absolutely. Let me copy this. And you can find me on LinkedIn, which I'll also post the link for. And you can find me on LinkedIn. I think I'm still sharing. View profile. Cool.
Okay, thank you very much. So to all the participants on the chat, do you have any more questions right now? So nothing there yet. So Adam, I guess you will be available at the breakout room for some time?
Yeah, definitely. Please, yeah, I'll jump over the breakout room. People want to have a chat with me one-on-one. And yeah, I'm keen to hang out, have a chat.
Okay, cool.
Right, guys. Well, I'll see you over at the breakout room if anybody wants to come over and have a quick chat with me.
Okay. Have a good evening, Adam.
Thanks, guys.
It's good speaking to you. See ya.